Grayscale AI is building neuromorphic software that helps robots and cars navigate their current environment using human-like precision and understanding. When we talk about neuromorphic computing, it's a completely new computing paradigm. So I thought that it's a huge opportunity to move the whole of technology and market in this new approach to processing data and interacting with the environment. I was one of the first people in the world to work with these new types of cameras called event-based cameras, also known as neuromorphic cameras. The imaging technology is different from what you would have on a traditional camera. Basically, this technology just measures the amount of light that hits the sensor, and when a certain lightning change is detected, a signal is emitted. So you would just output data when you see a movement or a lightning change. Because you are only capturing the changes in the environment, the amount of data that you need to process is orders of magnitude lower than the amount of data that is emitted by a traditional camera. What we're trying to do is coupling the neuromorphic camera with a neuromorphic chip. So we are able to analyze that data extremely fast at an extremely high energy efficiency, up to 10,000 times more energy efficiency than existing ways of processing things. We had two goals. One was to test our solution in real-world control scenarios using the UK testbeds that we had at our disposal. We work with 3 testbeds: AVL, which is part of Midlands Future Mobility, HORIBA-MIRA, and Smart Mobility Living Lab London. AVL has helped us tremendously in setting up the car and logging the data that we require. So we were able to integrate our system, integrate the neuromorphic camera and our software onto their vehicle. And we were then able to collect and trial our program on the routes of London via the help of Smart Mobility Living Lab London. And at the same time, HORIBA-MIRA helped us test our solution in controlled, specialized test scenarios at their proving ground. This would allow us to be in a much better position to get certifications for the product, so we can then really illustrate the value proposition for potential automotive clients. Today we went a route around the center of London. We collected multi-sensor data set. As you can see on the screen on the right, we have the footage from a traditional dash cam. It's fairly typical, but on the left, footage from an event-based camera, also known as a neuromorphic camera. And if you look closely, these type of cameras only detect the changes in the scene. So basically, as the car moves around, it will only pick up the edges or the lightning changes. In the near future, we want to help drivers have an automated system that would alert them of potential road hazards. We want our system to be able to alert the driver via an auditory alert or tactile alert that there's a hazard in front of them, so they can take appropriate action. Going through the process and collecting this type of real-world data has helped us identify a number of key scenarios where our product really shines in terms of identifying potential road hazards. So working with the testbeds has allowed us to get access to very specialized equipment that otherwise we wouldn't have been able to do the testing on. And I would estimate an accelerated product roadmap of about 9 months. We have been able to better illustrate the value proposition for new clients and investors. We see the company as being the center of neuromorphic computing in UK in the next few years. So we want to develop an ecosystem of other neuromorphic computing startups that are able to use our platform and later on expand worldwide.